This video describes the homework assignments that I use for a class at the University of Maryland to introduce students to natural language processing. These assignments are designed to get people up to speed with the tools and the foundation that you need to build a state-of-the-art question answering system. This video gives an overview of all of the assignments and how they fit together into an overall system that you could use to build a question answering system that could go head-to-head against top trivia players in a game like Quiz Bowl. Each of the individual assignments are relatively small, but they introduce along the way a series of components that together serve as a foundation to understand not just natural language processing fundamentals, but components that you can put together into an overall system. The first assignment helps introduce students to Python. This is the programming environment that we'll be using for the course and the programming environment that we use for a lot of the tools that we use in research as well. The introductory assignment is about creating an information retrieval system using term frequency, inverse document frequency representations of documents. In later assignments, we'll use more advanced representations from neural network models, but you learn a lot of useful tools by starting with these TF-IDF vectors. You learn how to represent documents as a single vector, and you use operations like cosine to compute similarities between different objects, such as queries and documents. Information retrieval is often a foundation of question answering systems. You can use information retrieval taking a question as a query, put that into the system, see what documents you get back, and either use those documents as your answers or use those documents as input to a more complicated question answering system. However, modern question answering systems are typically built on top of machine learning, so we need to introduce some machine learning concepts as well. One of the concepts that we'll introduce is that of a classifier, and the simplest way that you can build a classifier is with a nearest neighbor approach. We can extend our information retrieval representations of documents so that you have a query that comes in and you find the k-nearest documents to that query, and then you use those k-nearest documents to come up with a label that you want to assign to your query. In the language of question answering, your query is a question and the label is the answer to the question. So you find questions that are like the question that you got, and you give the answer of the most similar questions. This is not just a good introduction to classification, but it also is the simplest system that can be submitted to our online competition framework that is built on top of Codalab. And even though this is a very simple system, it's a strong baseline to compare against. You can have some pretty complicated systems that don't beat this relatively straightforward baseline. While a k-nearest neighbor classifier is indeed a classifier, it doesn't have a lot of the properties of modern machine learning techniques. For instance, trying to optimize the parameters of your model with respect to some objective function. These concepts are introduced in the next homework, where you build a classifier using the PyTorch framework to learn how to label the category of questions. So what is this question asking about? Is it asking about a novel from literature, or is it asking about a person from history? We'll learn how to create a classifier that can answer these questions using the PyTorch framework. We're not going to use many of the advanced components of PyTorch, but we will introduce the concept of having an objective function and learning parameters to some model with respect to that objective function. The next stage is we're going to start using PyTorch in the way that it's intended to be used. We're going to use PyTorch to learn representations using nonlinearities. We're going to be using hidden layers. We're going to be taking advantage of the full power of PyTorch to implement a model that was actually published somewhat recently. And this will get you up to the point where you can start modifying models to capture the phenomenon that you want to extract from text information to better answer questions. Thus far, we've been focusing on how to take a question and generate an answer. And in the next homework, we're going to focus on a different part of the problem, knowing when you have the answer correct. So figuring out whether your model is confident or not, and trying to time your model so that it answers at the right point. And so in the game of Quiz Bowl that I've talked about before, this amounts to buzzing in. How can you learn when to buzz in at the right time? And there are many ways to do this. In our baseline models, we use a simple threshold, but in this homework, we're going to use sequence models to look at the temporal nature of how the predictions of models change and what you should do with that. In addition to looking at more complicated models that have repeated structure and aren't of a fixed dimension, because sentences can be arbitrarily long, we'll also introduce the concept of modifying objective functions so that you can tweak models so that the objective matches what you want to do, so that your model learns to prioritize the right signals when it makes its decision. The last homework will be using a state-of-the-art model, using a state-of-the-art framework to actually answer questions. And we're going to go far beyond the simple classification-based approaches that we use to answer questions and use what's called a machine reading model. And so this is a very complicated model, but it's built on all of the things that we talked about. It uses an IR system to extract documents. It uses a sequence model to find what parts of the documents are relevant to answering a question, and then it uses deep learning to extract that and to decide what span is the actual answer to your question. And we'll put all of that together using a state-of-the-art framework to create answers to questions where maybe we haven't seen that answer ever before. If you're a student in my class, at this point you'll be ready to complete the project. If you're someone interested in participating in our question answering is not a trivial activity competitions, this will also provide a foundation for you to get ready for the competitions. And the goal of the course is to get people ready to create systems that can take on top trivia players in live human-computer question answering competitions. One of the things that I've worked on is building infrastructure and framework. For example, when we took on Ken Jennings at the University of Washington, we'll be using that same framework and bringing in some very strong trivia players to compete against the systems that are built in my class at the University of Maryland and against systems submitted from around the world on our CodaLab leaderboard. For my course at the University of Maryland, we have 3 days set aside for when student systems take on human teams. The exact composition and makeup of those teams will be a bit of a surprise, but hopefully it'll be exciting and fun. In June, we'll have another live competition where the best system submitted to our CodaLab leaderboard will take on the very best human team of trivia experts that we can possibly assemble. One of the things that I like about these competitions is that whatever you care about, there's almost certainly a way for you to fit it into this competition framework. If you care about syntax, you can work on that in the context of this competition. If you care about reinforcement learning, you can work on that in the context of this competition. If you care about digital humanities and you want to use novels to try to answer literature questions better, you can use that in the context of this competition. These models are good, but they could be a lot better, and nearly anything that you could do would help these systems work better. And you can focus very narrowly on sports or pop culture or video games, whatever you care about the most, and there will be some questions about that, and you can see how your system does on those particular questions. And what I think is most exciting is that you don't just see a number that pops up on a leaderboard. When you're done with your system, you can see how it does against the best trivia players in the world, and you can watch it live on YouTube. Let me close with a little bit of advice. While you can and should start talking to possible teammates and start thinking about what you may do for your project and for your submissions, I would encourage you to not get into the coding aspect just yet. You can start gathering data, you can start thinking about project ideas, you can start thinking about your team, but you're going to learn a lot by working through these assignments first, and that will give you ideas about what works, what doesn't, what's important for doing well at these sorts of competitions, and what's actually difficult for computers to answer. One of the reasons that we've designed these assignments in the way that we have is that they introduce the components systematically and they build on top of each other so that you can see what the data are like. What's important about guessing? What's important about buzzing? All of these components work together to make an overall question answering system that is effective, and you can see what works, what doesn't, and how to evaluate it. But above all, I hope that you have fun in working on submissions to our competition, and I look forward to seeing your system take on the best trivia players we can assemble.